Good day to everyone. Now I would like to present our Smart EV Charging Station Management System. My name is Kok Hao Ming and we are from Group22 and my team members are Guan Wei Yao, Charging and Tsai Wei Han. Now we'll take a look at the problem statement. Electric vehicle demands increases drastically in the whole world due to the increased supply of electric vehicles, which has started to become mainstream in the automotive industry. The number of users will only increase for the time being. To cope with this situation, the electric charging station vendors need to build more and more charging stations around the country. Although the more electric charging stations are better, some problems such as inconsistent user charging behavior have affected the efficiency of charging station usage and additional wait time. Secondly, at certain locations at certain times, the demand for charging station increases drastically. Therefore, the user is unable to predict the usage of each charging station during peak periods. This will cause the station overloaded. Lastly, most of the electric charging stations are currently inflexible in their power supply allocation, which causes energy waste. Therefore, this system aims to perform user behavior analysis and optimization, peak period prediction and allocation, efficiency enhancement and energy conservation in order to fully utilize the usage, reduce overload issues, ensure reliable power distribution and improve the user experience. The proposed solution uses Amazon Web Services to gather, analyze and visualize data on user charging behavior and charging station usage. This is our architectural diagram. We have two inputs. The first is user mobile device, and second is EV charging station. The system is divided into two parts, which is Smart Predictive Charging Patterns module and latest charging station occupancy status. The web services used will be demonstrated later on.
My name is Charging, so I made my part is mainly about the IoT call to DynamoDB. So the sensor data from EV charging station and user mobile device will be sent into the AWS IoT core, and the AWS IoT core will distribute the payload data to the Lambda, and the Lambda will mainly update the data and write it into the DynamoDB, which prepare for the charging station database and the user mobile static data database. So the IoT core should work successful if we show something like this. So in the IoT core, we create two things, that is user mobile and the EV charging station. So this for two different purpose. Then so we can test the IoT core by using the MQTT test client. So we need to subscribe to a topic first. So subscribe, then I run the script of the sensor, simulate the charging station sensor, publish the sensor data to the IoT core. So we can see that the data is published to the IoT core. So after the IoT core is received data from the charging station sensor, and so we use the before the data enter the DynamoDB, we use the Lambda. Then so the Lambda is a place to categorize the data input from the IoT core. That if the data is directly from IoT core and right into the DynamoDB, the table structure will abnormal. So Lambda is serves as a categorize the data. So we have 4 Lambda. So I will mainly say about 1 Lambda is enough. So for this Lambda, if we using the Node.js to run it, so we import the DynamoDB and database client. Then so we write the script to retrieve the payload data from the IoT core, then write it into the created table in DynamoDB. So after the data processed in Lambda, then the data will save into the DynamoDB, so mainly save in the charging station database or the user mobile database. So for the charging station database, so from just now, we can see that we have published the data from the charging station. For example, this S102 station ID S102, then the data. So it will write into this charging station database. So we can see that the data is tally. So it means that the charging station data is successfully write into the database.
All right, so in order to predict our available port in the charging station, we are using a service called AWS Forecast. So in order to use the AWS Forecast, we need to throw our data into the S3 bucket so that the AWS Forecast can use the dataset that we provide. So this is the example of the forecast result that it will give 3 machine learning to predict our dataset in the future timestamp. So first of all, you need to go to the S3 bucket and create a bucket and put in your CSV file that get from the DynamoDB. Yeah. So after you got the CSV file, you can go to the Amazon forecast, and here is view dataset group lah, but if you are first time, it will be a create dataset group. So you just click in, you create the dataset group. The domain I choose is custom because this is for our custom need lah, not retail or inventory planning or whatsoever. So after you create the dataset group, go in. Yeah, so the first thing is you need to import the target time series data. Yeah, so here you select the interval, the format, and after that the data location. So you can click the browse S3 and go into the bucket you created and choose the CSV file. So after that, after you created and it is active, you can go to train the predictor. So in the trend predictor, the forecast frequency is the frequency of the timestamp in your dataset lah. So the forecast horizon is how far in the future you want to predict. So after that, you enter all the thing you created, then it will start training the predictor lah. After you complete training the predictor, you can go to the query forecast. So you can choose the forecast you trained just now and choose the date, start date, end date to predict, and the timestamp. Yeah, so remember to add the forecast key. This is something like the primary key in your dataset. So enter the value. So I want to predict S101. So I get the forecast. Yeah, so this is the future value that predicted by the machine learning AWS forecast. So they will given 3 machine learning model to predict the result. And that's all for the AWS forecast from S3 bucket.
Now, I would like to present how we can virtualize the charging station data. First, another AWS Lambda function was executed to convert the charging station data from DynamoDB to JSON format, and the JSON files were stored in one of the S3 buckets. Subsequently, AWS Adina is employed to execute queries on the JSON files stored within S3, extracting relevant data for analytical purposes. Following this, AWS QuickSight is utilized to generate virtual representations of the query data, facilitating comprehensive and insightful dashboard for both users and administrators. Now, I would like to demo on how we can virtualize the charging station data. So this is the DynamoDB table, and this is our record. First, we create a Lambda function called backup charging station, and we go to the configuration, permissions, and make sure that this Lambda function has been assigned with DynamoDB and S3 permission. After that, we move on to the code. Then we define the bucket name, table name, and use the scan command to scan through the table and retrieve data. After that, we create a file path and put the station data as object to S3. And this is all the JSON files. Now we can move on to AWS Adina. First, we need to create a database. We click create S3 bucket data. Then we key in the table name. We choose create a database. Enter the database name and also the location of the input data set. We click browse and select. After that, for this one, we choose JSON and enter the column name. After that, we click create table. After we have created table, the table should be over here. Then we can click here and preview table. So this will query the data like this. And this will be the result. This is the 10 record. And as we can see, the status is in array format. Now we need to retrieve all the data from the array. We'll use this query. And now we can see that the charging port amount available and timestamp has been taken out from the array. Now we can move on to the output bucket, and as we can see, this is the result of the query, and the query data will be stored over here. Now we move on to the quick site. Over here we click new dataset, S3, and enter the data source name. And here we can choose to upload an manifest file. And the manifest JSON file is something like this. So this would be the file location of the dataset. Then we click connect. And now we have finished data set creation, and we can click virtualize. After we click virtualize, it moves on to something like this. And now over here, we can click add virtual and choose one of the chart. After that, we can drag and drop the field over here. Now, a chart is successfully created.
Now I will discuss the module of latest charging station occupation status from DynamoDB to API Gateway by using the AWS Lambda function. And this is the outcome of the module. It shows the station data, station forecast data, and user forecast data on this page. First, this is the DynamoDB, and this is the table. We can saw that it got some of the data inside the DynamoDB. Then we gonna to use Lambda to get the data from the DynamoDB and pass the data to the API gateway. Then we can access to the API gateway by using the link. And here is the link for access to the API gateway. And we can saw that this page will show all the data here. That's all from me.